Hi, good day. This is further meteorological analysis prepared by Dr. N.O. Nolly. And this further meteorological analysis involves scalar and streamline analysis. So this lecture one will involve mainly scalar, and that is isobaric analysis, and it will last for 10 minutes or less. This scalar analysis or isobaric analysis involves a weather map, surface weather map. Surface weather map will be used as an example. Already, the surface weather map you are looking at is the one gotten or taken on the 27th of February 2013 at 12 GMT. So what is carried out here is mainly isobaric analysis, that is analysis of pressure. The map you are looking at has a very low resolution. That is why the station circles are very tiny. It is difficult to see very well the values measured around the station, that are labeled around the station. And because we look at, when we consider the procedure of analysis, we consider areas that are, we start from areas that are dense and then move to areas that are not dense regarding data. And from here we see that the areas that are dense are the European area. So for this reason, this map has to be cropped and such a way that we have only the European area, and will now be expanded to make it have a higher resolution so that we can see values at the station. And that is what is done in this next slide. So this next slide shows the cropped weather map, and it's only for Europe, and it's enhanced. As I said, this has been already analyzed, but we're looking at, I'm trying to guide us on how the analysis was carried out. First and foremost, looking at the station circles. Look at the station circle, you see the wind value here. Wind is there, but we're not analyzing wind. This is the wind barb, and then this is 10 knots. But we are looking at values at the top right hand corner of the station circle, and that is the value of pressure. Like this station you are looking at, the value there is 991, or rather 993. To the left of it, you see 995, that's this. Then south of it, you see 991. Then to the right, you see 990. Then to the right again is 1002. 1002, that is to the right of it here. Here is 992. Here is 988. And so forth. Till you come to this area of the low, you have this to be around 950 or so. And this is this should be 953, this is 950. So in analysis, we can start from 1,000, standard value starting from 1,000. Then we can now increase and reduce as the case may be regarding values at the station. So if we now analyze 1,000, we have it like this. First and foremost, we look at stations around. See that 1,000 line can pass between those two stations. For example, here we have 988, and over far from this side we have this is 1,011. So 1,000 definitely will pass here. So this 1,000 is now drawn to pass like that. And then as you are drawing, you come nearer stations. You check whether the 1,000 can be accommodated there. It can pass through there or not. This is 995, and here is 1,011. So definitely the 1,000 will pass. You continue down to the south. Then to the left here we have 1011 or so, 1011 or 1009 rather. Then to the right we have 991. So 1000 exists between 991 and 1009. So the line now goes like that and goes south of this particular station, then continues. We look to the right hand side, we see 1009 here, 991. So 1000 will pass between 991 and 1009. So we'll just continue. This station is 990, so 1000 will now be south of it. They will come to this is 1002, so higher than 1000, but here is 990. So 1000 will exist between 990 and 1002. So the line goes north of this station. Then the line comes towards the south again. This is 996. So 1000 will be south of it until we get to this point where it now we level it. The same thing is done for this, the next one, the 992 line. When you subtract, we are using interval of 8 because the way the map is, usually is interval of 4 hectopascal will be used, but the map is, when we use 4, it will be very compact, so we are using 8. So when you subtract 8 from 1000, you have 992. So that's the next line to be analyzed. And of course, this station here is already 992, so we take it through there. Of course, considering this one, 992, and this is 993, higher than that. So it passes through here and then goes to this point and stops here. The next is 984. When you subtract 8 from 992 is 984. Subtract under 8 is 976. These two lines can be drawn, but when it gets towards this right hand corner, it becomes compact. So I stopped. I didn't label it there, only here I label it there. The next is 960. Sorry, no, 968 rather. And then finally 960, which I couldn't label here because of these values that are here. So the 960 is now drawn like that. I only label it here. And then that's the last we can analyze because the other ones are lower than 960. So we'll put a low here. Then the same thing can be done towards your left. To the next value, if you add 8 to 1000, you have 1008. So this one can now be taken around like that. This is 1011, definitely will be to the right of it because to the left is increasing, to the right is decreasing. So 1008 will pass here, and this is 1009, so it just goes to the right of it, and then like that continues looking at all the values. You take it around like that, like that. You continue until ensuring that the line will normally exist between two stations with values that can accommodate 91,000, 1008. So we now stop here. Then looking at this area, you have after analysis of 1000, because it's now it's decreasing in size, so definitely you have 1000 here and 1000 there. So there are two lows existing between the inside this analyzed area. And then after this, we can take the next analysis. 1016. 1016 is there, it goes around like that. Of course, as you draw your lines, you check for the values to ensure that 1016 will be accommodated, can pass through those two stations. Then you take it around like that, 1016, and the 1016 continues this way down, and then like that, and then like that till it gets there. So that's how the analysis is carried out. It continues like that until you have all these values analyzed, and then you insert the high pressure. This one will be a high 1020, and this is another high inside here. Okay, so and there's another high here which is more than 1020. So that's how this is carried out. Other ones you can do looking at values of stations to ensure that the values can pass through the two values of the station. So at this juncture, this first lecture will end because it's for 10 minutes.